ShadowRay 2 is a campaign that exploits AI infrastructure to create a self-propagating botnet. The attack leverages AI frameworks to take control of compute clusters. The operation turns legitimate, intended features of the open-source Ray AI framework into attack vectors. These features are used for autonomous propagation across exposed Ray clusters, building a botnet for cryptojacking, data theft, and other malicious activities. The entry point for the attack is a known vulnerability whose status is disputed. This classification has resulted in it remaining unpatched. The specific vulnerability is CVE 2023-48022. It enables unauthenticated remote code execution through the Ray Jobs API. Framework maintainers classify this as disputed, arguing Ray is designed for use only within secure, controlled networks and should not be exposed to the internet. From this perspective, it's considered intended behavior, so no patch has been issued. Despite the design intention for controlled environments, more than 230,000 Ray servers are exposed to the public internet. This exposure creates the large attack surface for the vulnerability. The campaign employs a structured operational playbook. The initial phase of the attack utilized infrastructure hosted on GitLab. First, attackers discover vulnerable targets at scale using out-of-band application security testing, or OAST, platforms like interact.sh. They send out payloads, and when a vulnerable server is hit, it makes a callback to an attacker-controlled domain, confirming its exploitation. Initial access is then gained through the unauthenticated RayJobs API to execute commands. The payloads are composed of multi-stage Python and Bash scripts. An analysis of their structure and embedded comments suggests they were generated by a large language model. The scripts are designed to first discover system resources like CPUs and GPUs, and then they limit CPU usage to 60% to help evade detection. They also use base64 encoding for obfuscation. Once inside, the attack spreads using a native Ray feature called Node Affinity Scheduling Strategy. This allows the malware to execute on every single node within the compromised cluster. To maintain persistence, cron jobs are set up to re-download the payloads every 15 minutes, and for evasion, the malicious processes are disguised to look like legitimate kernel workers or system services. The attackers also deploy scripts specifically designed to eliminate competition. These scripts scan for and terminate processes belonging to other cryptojacking operations. They also modify the system's host file and IP tables rules to block all network traffic to rival mining pools, ensuring all the compromised resources are theirs alone. The campaign also features a location-aware delivery system. The payload first checks the victim's geolocation using ip-api.com. If the IP address is located in China, a different specialized payload is delivered. This version uses proxies to get around regional network filters. After the initial campaign infrastructure was taken down, the attackers didn't just disappear. They adapted, re-established their operations on a new platform, and came back with even more advanced tools. The timeline here really shows their agility. On November 5th, their GitLab repository gets taken down. Just 5 days later, on November 10th, they're already back online, operating out of a new repository on GitHub. Then, when that GitHub repo is removed on November 17th, they have a new one up and running in less than 2 hours. In this second wave, the attackers used a more sophisticated LF unpacker. It was a custom dropper that used LZSS compression and executed code using direct system calls. This is a technique specifically designed to bypass security tools that monitor calls to standard libraries. And this new approach was incredibly effective. In the new mining pool they joined, the attacker, going by the name IronEarn440, quickly rose to the #1 rank out of more than 100 miners. This top spot indicates they had amassed a very high hash rate from their botnet. But this campaign was about more than just mining cryptocurrency. The compromised infrastructure was effectively a multi-purpose botnet used for data theft and launching even more attacks. Attackers were able to access and steal a wide range of sensitive data. This included proprietary AI models, the full source code for applications, and production database credentials. They also got their hands on cloud security tokens and any other user data that happened to be on the compromised machines. The botnet's capabilities were also weaponized. The SOC stress tool was used to launch DDoS attacks specifically targeting TCP port 3333, which is commonly used by other mining pools. On top of that, the botnet was used to propagate itself, with compromised nodes constantly scanning the internet for other exposed RAID dashboards to infect. This ShadowRay 2 campaign highlights a complex security challenge.
The attack's primary vector isn't a bug, but rather the intended, designed-in functionality of the target system. This approach complicates threat detection models that are built to distinguish between legitimate use and malicious abuse.